Okay, hi guys. Welcome to your part one of your daily video. It is April 23rd, and today we're going to be talking about transformations from A in our radical function. So still in Unit 4, we're in Section 2 now, looking at transformations from A. Before we get started really fast, please keep in mind that your mid-quarter check-in grades are due for me on the 24th, which is tomorrow or Friday. I explained this a little bit already, but here's just a quick reminder for you. At the very beginning of this quarter, when we started our online stuff, I sent you some criteria for how I'm going to grade you. So I told you I was going to look at 3 things. Are you participating by completing the daily assignments? Are you working for accuracy, meaning like are you doing the math correctly to the best of your ability? And then on any formatives or summatives, I would grade on accuracy. And then the last thing is just, are you showing me that you care? Like, are you turning stuff in on time? Are you communicating with me? Are you responding to emails when necessary? Are you coming to office hours if you need them? Are you asking questions if you're lost? That kind of thing. So for your mid-quarter, you're going to get one of 3 letters, so you'll either get an S, a D, or an F. The S is for satisfactory. You earn this by completing 50% or more of the online assignments for the 4th quarter. So remember, these letters are just check-ins for the 4th quarter. Basically, the S just means you're on the right track for earning a passing grade, and eventually this will become an A, B, or C based on like this stuff up here. Right now, it's just going to be like, yes, you're on the right track, or down here is like, no, you are not on the right track. So if you see the S coming home, that's a good thing, and then later on, that will become an A, B, or C. If you see a letter D, that means you are in danger. So this is for students who have completed less than 50%. So you've done less than half of the work that I've assigned, and it just means you're in danger of failing for the quarter, because you're doing less than half of the work. And then if you see the letter F coming home, the F is for students who are failing at quarter 3 and who have not completed any of the assignments. So this is like you are failing right now because you were failing at the 3rd quarter and then you haven't done anything since then. So there are not very many of these Fs that will go home, but I do have a handful of people who are in danger just because they're doing less than half of the work. So the S is good, the D is like, hey, we better turn it around, and if you see an F coming home, you better email me immediately, and we have to make a plan to get you guys back on track. We are winding down here to like less than a month left of school coming up, so we got to make sure we're staying on top of it here for the next couple of weeks, okay? Okay, so agenda for today, I'm giving you 2 videos today just to kind of break it up a little bit here. The video 1 is for the notes. I'm just going to go through this slideshow, and then video 2, I'll actually do some examples on the whiteboard. Okay, so quick reminders. We talked about standard form for radicals, where we had A being multiplied on the outside, C being added on the inside, and D being added on the outside. So we had a couple of examples. You may get something that looks like this. So in this first one over here, we have A is 5, C is that -7 here, and 3 is our D value. And then on this one, remember that if there's nothing out in front, there's an invisible 1. So A is not allowed to be 0. If there's nothing out there, it's a 1. And this negative sign makes A a -1. C is also -1 in here. D is allowed to be 0. So if there's nothing on the outside being added or subtracted, that makes our D value 0. So A cannot be 0, but C and D can. So if there's nothing in the front, there's a 1. But if there's nothing in here or out here, then C and D are allowed to be 0. Okay, so that was on our first set of notes for this section. So if you're confused on that, go back and look at that video and that slideshow. Okay, we're going to talk about A's jobs today. So I think you wrote this down. You should have written this down already because I briefly went over it. And I told you A is for alter. Okay, that's our key word here. A is for alter. So A can flip, and then A can stretch or shrink. So there's kind of 3 things we'd want to be looking for here. Stretch and shrink kind of go together, but those are the three things that go along with A. Okay, so we're going to talk about this, and I'm going to show you how to figure out if we're flipping, stretching, or shrinking. So here's a flip. Okay, flip is, this is what it looks like. So the dotted line right here, the red function, this is our parent function. Okay, and if we have a flip, what that means is just instead of pointing up and over, now it's pointing down and over. So it just becomes negative. So it dips down here into the negative numbers. So our rule is we flip if A is negative. So for example here, right, we have that positive 1 in front on our parent function. So positive is going up this way. And as soon as we get a negative sign out in front, so on this function down here, A is a negative 1. The negative sign out here is what creates the flip. And the flip is just, instead of going up, it's going down. It's always going to go to the right in this class. But the flip just does exactly what it sounds like, flips it upside down. So if your A value is negative, the graph is going to flip. Okay, so there's your first transformation. If A is negative, the graph flips. Okay, flip if it's negative. Then we have a stretch, okay? So this is like a little flashback here, absolute value. We'll talk about that in a little bit, but your rule, okay, for a stretch, we stretch if the absolute value of A is greater than 1, okay? And we'll talk about that a little bit. But just know that a stretch, so if you notice here again, the red dotted line, this is our parent function, so this is the original, okay? And the stretch just means we're basically just stretching it out and it's getting a little bit taller. So it starts at the same point, right? Nothing has really moved. All the graph has done is just stretched out and it's gotten taller. So it's like we're just pulling it upwards. It's just stretching out, okay? Now, absolute value, this is like how many spaces away are you from 0? So we'll talk about that in a little bit, but notice here, our absolute value is 1, okay? This one, our A value is 1 here, okay? And then this one, our A value is 2, okay? The absolute value of 2 is 2. It's 2 spaces away from 0, okay? So the absolute value of 2 is 2. 2 is greater than 1, okay? So if your A value is bigger than 1, okay, when you check its absolute value, that means the graph is going to stretch out, okay? And I will give you lots of examples on this, so just hang with me for a second, okay? But a stretch is when our graph gets stretched out tall, okay? It just gets taller. And that comes from our absolute value of A being larger than 1. So here the absolute value of A, which is 2, okay? So that means our graph is going to get stretched out taller. Shrink is similar to that, but now instead of getting stretched out taller, it's just getting squished down. So here is our red parent function, and then if you notice, the shrink just means it got shorter. So a stretch is when it pulls up higher, and then a shrink is just when it gets shrunken down. So again, it hasn't moved from the origin, the shape hasn't really changed, it's just gotten shorter. Okay. This one comes from our absolute value of A being less than 1. Okay, so here our A value is 0.5. Okay, the absolute value of 0.5 is 0.5. It's a half a space away from 0. And that is less than 1. So that means our graph just gets shrunken down. So our absolute value of A is smaller than 1, so our graph gets a little smaller. Okay. So here's some notes on that for you. So when we talk about the absolute value for the stretch or shrink, the absolute value is just basically asking, okay, how many spaces away from 0 is this number? And your absolute value will always be positive, okay? So if I were to ask you, what is the absolute value of 5? 5 is 5 spaces away from 0. So the absolute value of 5 is 5. Similarly, if I were to ask you, what is the absolute value of -5? -5 is still 5 spaces away from 0. So the absolute value of -5 is still 5. So that's what I mean here. Just it's always going to be positive because we don't care about which direction we're going, either up for positive or down for negative. We just care about how many spaces we're traveling. So if you imagine that number lines, like the ones that are taped on your desk, right? +5 and -5 are still 5 spaces away from 0, right? And then same thing works for decimals. The absolute value of 0.75 is 0.75. Even if this were negative, right, the absolute value of -0.5 would still be a positive 0.75, okay? Okay. Also, just, I guess this should be kind of obvious, but I get this question sometimes. We can't stretch and shrink at the same time. So we can't get taller and get shorter at the same time, because our absolute value can't be bigger than 1 and smaller than 1 at the same time. So you either have a stretch or shrink, not both, one or the other, or you have neither, okay? So it is possible to have no stretch or no shrink, and that's where people get confused sometimes, I think, okay? So you can't have no changes. So for example, if A is positive, you have no flip, right? If it's not negative, you're not going to flip. So having no flip is perfectly fine. And then here, if the absolute value of A is equal to 1, okay, so it's not bigger than 1 and it's not smaller than 1, then we just have no stretch or shrink at all, which is perfectly fine. You're not going to have all of these at the same time on every problem. You may have no flip and you may have no stretch or shrink at all, and I'll kind of show you what that looks like. But just know that if your absolute value of A equals 1, 1 is not bigger than 1, 1 is not smaller than 1, so you're not going to stretch and you're not going to shrink. You get neither, which is a perfectly fine answer as well, okay? So those are the notes for that. There actually is a foldable that I make, and I will post a picture of my foldable so you guys can see it, but basically it's similar to the ones we've done before where we make the little flaps, and I have one flap for A and one for C and one for D. So I will post a picture of that. If you guys have paper and scissors, that's really all you need. If you would like to make the foldable, that might also be helpful for you. So I will post a picture of my foldable. But for now, you guys are finished with notes. So go ahead and head over to the daily video part 2, and I'll show you some examples of what this looks like. Okay, nice job. Go get ready for examples.